So students, let's come up with the lecture 4 of class 11. Okay. So in the last class, what we have seen the concept of integration. Okay. In the last class, we have seen the concept of integration. Okay. Yeah, I was about to do some sort of examples, but I thought the video got cut somehow. Okay, it was cut in between. So okay, nothing to worry. We will be completing it today. Okay, just hold on a second. So what we have done in integration and differentiation, we will be seeing the application of both. Okay, we will be seeing the application of whole thing. Okay, just one example, then we will shift to motion. Okay, suppose you take a function. Suppose you take a function fx, signifies the function is dependent on x. Fx signifies what? The function is dependent on x. Let's say you take an example 3x square minus 5x plus 10. Okay. Suppose you take an example, a function is dependent on x. If I need to find slope at x equals to 2, what it signifies? Slope at equals to 2 means we have to do dx of the function fx. We have to do what? We have to do dx of the function fx. So what you get over here, 3 remains as constant, x square, it will be 2x, minus 5, let it be 5, and differentiation of x is 1, plus 0. So it comes out to be 6x minus 5. This is a generalized concept of the slope, or we sometimes write it as f dash x. We sometimes write it as f dash x. Now what we need to do? We need to find the slope at x equals to 2. So f dash 2 comes out to be 12 minus 5 is equals to 7. Wow. This is the basic thing. Now if I say another function, say the function is 3x plus 5. The function is 3x plus 5. Now we need to find area between x equals to 2 to x equals to 4. On which axis? On x axis. That means. So we need not to draw a line. We need not to draw any sort of line. We know this area means area under which axis? Area under x axis. What we need to do? We need to do the integration. Integration of what? Fx dx. Fx dx. From where? From x equals to 2 to x equals to 4. So from x equals to 2 to x equals to 4. Okay. So this is the basic concept. Answer how you do this thing. Let it solve you. 3x plus 5, say dx from 2 to 4. So first case, integration of 3x dx from 2 to 4 plus integration 2 to 4, 5 dx. Okay, so we can solve this thing. No need to draw the diagrams. Okay. So this was the basic application. Now how we are using these applications in motion, that is the most important thing. Now we are still left with one important portion of mathematical tools. We will be doing that in the chapter of motion in 2D. I am not delving too much into that. Okay, we will be doing that in the chapter of 2D. Okay, there we will be clearing it out. It's a bit concept of parabola, okay, not a huge concept. So right now what we have understood the basic concept of integration, the basic concept of differentiation, what is slope, how to draw a straight line, everything we have got. Now we will be straight away doing the concepts of motion. And yes, I will be sending you worksheets in PDF in your WhatsApp group. Okay, those who are in the WhatsApp group, I will send you, and we will be discussing the detailed solution in the video lecture also. Okay, so note it down. We start off with integration. motion to 1D. Now, when we start off with motion in one dimension, what this one dimension signifies? Simple thing. One dimension signifies any motion which can be represented in a straight line, Simple one-liner, sir. What is one-liner? It is straight line motion. Means everything must be happening along the straight line. So now this straight line can be this axis, this straight line can be like this axis, this straight line can be this. So any straight line, it has to be any straight line. Now, so this is basic of what is motion in 1D. Now, what all we require to study motion in 1D? First, most important thing, we need a reference axis. Now, this is very interesting. What is a reference axis? Reference axis can be your x-axis, can be your y-axis, or any axis of your choice. Any axis. Suppose a particle, this is suppose this is a ground, say this is a wall, or this is a wall, okay. A particle is moving like this way. A particle is moving like this way. So what you say, sir, this is x-axis, this is y-axis, the particle is moving like this way. So the particle motion is related with x and y? No. You can do one thing, you can choose this as the axis, which you name this thing as x dash and you name this thing as y dash. Then what happens? Then the particle motion can be expressed along which axis? Can be expressed along x dash. So this reference axis we can choose accordingly, but it has to be a straight line. It has to be a straight line. Now, this is the first reference axis. Next important term is the observer. Now, this is very interesting. Without observer, you can't describe any sort of motion. Suppose if I be the observer, if anyone be the observer, we need an observer to describe the motion. Okay. Now, who is the object? Anyone can be the object. Other has to be the observer. So, we need an observer. We need an object. And the most misconception thing which the students have is t equals to 0. I will be coming on to this t equals to 0. And choice of sign. Now, choice of sign. What is this thing? So first, what all the things we require? We require a reference axis. We require an observer. We require an object. We require t equal to 0. And we require a choice of sign. These are the most critical points, most easiest point and the most critical points of motion in 1D. We need to clear out one by one what is this thing. So, choice of axis, it can be anything, done, yes. Now, what is the choice of sign? Choice of sign signifies if the right hand side is positive, then it has to be negative. If I say if upward is positive, then downward has to be negative, or else if upward is negative, then downward has to be positive. See, sign convention is according to the observer. Sign convention is according to the observer. Okay, clear out. So this is the basics we have done with motion 1D. Now we will be presenting each and everything one by one. Okay. sir, who is an observer? Now, observer is the most important part of motion quantity. Observer can be anywhere on the axis. Now, here we go. We use a term, position of the observer is on the axis. Position of the observer is on the axis and observer is assumed. See, I am using the term assumed, okay? Assumed to be at rest. The observer is assumed to be at rest. This is the first important thing. On the axis, suppose on any axis, object can be anywhere doing whatever. The observer is at rest and lying on this axis. Next comes the concept of t equal to 0. I have seen numerous students who have passed class 12. When I asked them what is t equal to 0, suppose in an interaction I was asking, see how we have done the results, what is t equal to 0? They say t equal to 0 is a very easy thing. The t equal to 0 signifies the body starts from rest. This is absolutely wrong. T equal to 0 signifies the body starts from rest. Those who says this thing, this is absolutely wrong. T equal to 0 does not signify the object starts from rest. Then what t equal to 0 signifies? The t equal to 0 signifies starting time count. Starting time count of the observer. The starting time count of the observer means the moment the observer start counting his time or her time, that is t equal to 0. Now, so at t equal to 0, object can be anywhere. Object can be anywhere on the axis, and can be in any state. What do you mean by any state? Any state means either at rest or at motion. I don't know. We need not to know. It can be anything. So, suppose if I am standing over in the Garyahat mode, so without having any sort of work, just enjoying my time standing at Garyahat mode. Suppose a bus is coming in this line, okay? I want to study the motion of the bus. Suppose I started noting the time. At this time, the bus was over there and it was in motion. Okay, so the bus can be anywhere on this line and it is in motion. It does not mean the bus has to be at rest. Yes. So t equal to 0 signifies the moment I started counting this time. So when I started counting this time, the bus can be anywhere on the line and the bus can be at any state, okay, either at rest or at motion. So first, where the bus is. So over here we will say something named as the position of the object. Now this is a very important thing. Position of the object with respect to observer. Means who actually study the object? Observer actually studies the object. Position of the object with respect to the observer. This is the most important point. Now, in general, observer is in assumed to be at 0 position. In general, observer is assumed to be at the 0 position. Means suppose this is the observer and say this is the x-axis out of which this is positive. You have chosen everything. Say sir, this is the x-axis as for our example. This is positive direction, perfect. This is the observer. So here comes x equal to 0. So this one becomes x equals to 0. Okay. So this is a general assumption. Okay. In general, observer, this is observer, is assumed to be at 0 position. Okay. Clear? So observer, object can be anywhere on the line. Object can be anywhere on the line and can be in any state. We will see it. Okay. So this is the first important points of motion in 1D. Then we shift to the next one. Now, so what we have sir, we have observer, yes, we have t equal to 0, we have an axis, see, and we also have an object. We have all these things right now. Now we will start our study. We have this axis, we have assumed this axis as x-axis. We have assumed, say this is observer and this is assumed to be x equal to 0. Okay. And so yeah, this is positive. Now where is the object? Where is the object? Object can be anywhere. Now if object is towards right of the observer. Suppose the object is over here and object is moving in this way. When it is at t equals to 0. So at t equal to 0, suppose the object is over here. Let's say the separation between them is 200 meter. Let's say the separation between them is 200 meter. So how you write the same? So we say xt. Now this xt signifies position of object with respect to time. This is the expression I will write. And who does this thing? It is the observer who decides. It is the observer who decides. So you write x at t equal to 0 is equals to plus 200 meter. X at t equal to 0 is equals to plus 200 meter. So it can also happen that x is same as the position of the observer. X can be in the object can be in the position of the observer. If that happens, if the object and the observer is at the same point, if the object and the observer is at the same point, then position of the object at that instant has to be equals to 0. If suppose object is over here, observer is over here, at any instant, suppose at any instant, if at any instant, object is moving where we are not worried. I am just stating the position. The object is in the left side of the observer. So x at that instant, it has to be a what value? It it has to be a negative value to signify your object is on the left of the observer. And what is the velocity, sir? Sir, we are coming on to the velocity. Okay. First, we are defining the position. Then we will defining the displacement. Then we will defining the distance. Then we will come on to the velocity. Okay. So this we have discussed about the position. Okay. Now, students, one term for displacement. You have done many expressions. Displacement is a straight line joining the initial position and the final position. Perfect. We have done all the things in class 9. Right now, one word we will be done. Only one word. Displacement is an invalid term. Hey, find the displacement. No, you can't do. You can't do like this way. You have to find displacement between any two time instant. Displacement between any two time instant. We have to find the displacement between any two time instant. Suppose t equal to 2 seconds to t equal to 10 seconds. If I say find the displacement, you can't find the displacement. There has to be two time instants in which we will find the displacement. So displacement between two time instants, say t equals to t1 to t equals to t2. Say t equals to t1 to t equals to t2. So how you express this thing? Sir, give me a one-liner. It will be expressed as x t2 minus x t1. This is equals to displacement. Nothing more. I will show you with the help of an example. I will show you with the help of an example. This is star. Only one-liner x position at the time instant t2 minus position at the time instant t1 will give you the displacement. But so let's show you with an example so you will be clarified. Okay? Chalo. So you note it down. I think this is clear. Okay, so let's come up with an example. Suppose this is x equal to 0. Now whenever I write x equals to 0, that signifies the observer is at x equals to 0. A, B, C, D, E. See, I am writing the 5 positions. I am writing the 5 positions, okay. Now let us say in this way. A is, okay, something do like this. These are all 100 units. Okay, now say object was over here. It goes like this, then it comes like this, then it goes like this. Okay, it is moving like this way. Okay. So if I say this was t equal to 0, fine. This was t equal to 1 second. When it came to b, okay, this was t equal to 2 seconds. Then it crosses this point. Okay, this point is termed as O. This is t equal to 3 seconds. This is t equal to 4 seconds, and this is t equal to 5 seconds. Okay, check it out. So first, how you say? Sir, first I say x0 means position of the object at time equal to 0. Where? Sir, it was over here. How much? Sir, it is plus 100. Done. X at t equals to 1 over here. From this position, it is how much? It is plus 300. X at position 2, time in 2 over here. Sir, from this position, how much? Plus 200. Sir, position at time equals to 3. Sir, it is over here only. So it is 0. Sir, x at time equals to 4. So it is over here. it is minus 200. Sir, 5, it is over here, it is minus 100. Done. Now, if someone says find the displacement, from t equals to 2 to t equals to 5. Sir, one thing, x5 minus x2, done. Sir, logically I will explain. Sir, when t equals to 2, it was at which position? It was at position B. At t equals to 5 over here, it was at position D. So from B to D, see, from B to D, how it has moved does not matter. How it has moved does not matter. We are only worried about from B to D. Finished. So B is 200 and D is 100. So from B to D it will be 300. But in which direction? In which direction? In this direction. So the displacement will be minus 300. Now we'll check it out with this concept. So what is x5? x5 is equals to minus 100. Give a minus. What is x2? It is plus 200. So the displacement signifies minus 300. The displacement will be minus 300. So this is the beautiful concept of displacement. Now if anyone says distance. Now distance is very tough thing. Now distance is different from displacement. See, distance is the actual length. It is the actual length. Means the exact length the object has traversed. Now sir, how to find the distance? Not now, later on. We will be finding the distance, everything later on. Yeah, logically you can say from right now. So logically means sir, 2, it was over here at time 2 seconds, it was over here. It has crossed in the extreme, then it has gone over here. So from 2, it has gone the total 400 plus 100. So distance will be equals to plus 500. So distance is the actual length. Okay, distance can't be negative, but displacement is a man-made concept. So displacement can be negative. So I think we have got the concept of what is displacement. Distance we will be finding the later on how to calculate the distance. Okay. So next we are coming on to the concept of velocity. Okay. Now, this time, what is velocity? Wow. Sir, what is velocity? There is nothing called the term velocity. It's a wrong thing. Sir, what you're saying? There is nothing called the term velocity. There are only two terms possible. One is average velocity. Another is instantaneous velocity. Two things can happen. One is average velocity, one is instantaneous velocity. Now this is man-made concept. This is okay. This is practical. This is only theoretical. And this is practical. So how? Let me explain. Sir, average velocity 1 by 1. Average velocity is not, you can't say average velocity. Average velocity between two time interval. Average velocity between two time instants is simple. Sir, x at t2 minus x at t1. by t2 minus t1. This is average velocity. And what is instantaneous velocity? V instantaneous means in the same concept, when the difference of the time interval tends to 0, yeah. When the difference tends to 0, we use this term as what? Yes, we use dx by dt at that instant. At that instant. We need to find the instantaneous velocity at that instant. That is V instantaneous. And V average is a theoretical concept, nothing more than that. Okay? Nothing more than that. Next. Okay. Next, we will be showing everything, examples, everything. Okay. We will be coming up with the term of acceleration. See, just let me give you some basics. You know all these things. What is acceleration? The rate of change of velocity. Wrong. Acceleration is not the rate of change of velocity. Huh? So what you're seeing? We have been doing this thing from class 9. Acceleration is rate of change of velocity. No. Acceleration is not rate of change of velocity. See, I am writing this thing means in my board and this will be published in the YouTube channel. If teacher sees this thing, they will give me all the galis. But yeah, I can challenge them. Acceleration is not rate of change of velocity. Sir, then what is acceleration? Now, I will write the same thing in a modified way. Wow. Acceleration is a measure, or I better use it. Acceleration is the cause and change of velocity is the effect. Now, what it signifies? If I say acceleration is the rate of change of velocity, that signifies that first velocity changes, then acceleration happens. No. Acceleration is what? When you give a force, it produces an acceleration. Force produces an acceleration. Acceleration produces the change in velocity. Okay. Take this thing. And how you measure acceleration? Then how to measure acceleration? Two things you can measure acceleration. If you know कि अगर तुमको पता है कि force कितना लग चुका है, तो तुम्हें acceleration पता होगा, okay? कि force by mass. But अगर हमको force नहीं पता, if I don't know how to calculate the force, फिर तुम acceleration कैसे calculate करोगे? फिर हम लोग acceleration calculate करेंगे by rate of change of velocity. So acceleration is calculated by rate of change of velocity. So acceleration is not the rate of change of velocity. Acceleration is what? Acceleration is because of the force. और वो क्या होता है, कैसे होता है, वो भी हम लोग देखेंगे. Okay? So एक होता है कि continuous तुम किसी बॉडी को धक्का दो. Continuously you are pushing a body. Means force is constant. Okay? एक हो सकता है कि you give a tight slap. Instantaneous force. Force at any instant. Means if I give a tight slap to anyone's face, the force is instantaneous. The moment the hand is in contact with the face, that's the point the person receives the force. So it produces acceleration for a moment. Okay? But if I continuously put my hand on the face and do like this thing, this will be a constant acceleration, or acceleration is continuous in nature. The acceleration will be continuous in nature. So two things, acceleration can be continuous, acceleration can be instantaneous. Okay, so we will see to it. Okay, so acceleration is caused because of the force. But how to measure acceleration? We will measure acceleration with the rate of change of velocity. Okay, So this is one of the most important board. Have a look. So over here we will have some concepts कि सर ये जो एक्सेलरेशन है ये क्या है, एक एवरेज हो सकता है या फिर एक इंस्टेंटेनियस हो सकता है, या दिस इज द थिंग. So acceleration can be average. See, this is also a concept. This is also a concept. It signifies sir same thing from t1 से लेकर t2 तक. How you are calculating acceleration from t1 to t2? This is simply a concept. Okay, that means velocity at time t2 minus velocity at time t1 divided by t2 minus t1. And what is acceleration? Instantaneous. मतलब उस वक्त acceleration क्या था? dv instantaneous by dt. Now acceleration instantaneous at that instant. Okay, so this is this. Now people say, sir, if I say the constant accelerated motion, yeah, we will be coming. So first we have two things, ki what is average acceleration and what is instantaneous acceleration. Now we will be coming up the two things we have in syllabus. One is constant accelerated motion. Now this constant accelerated motion, yeah, this is only one topic, no two topic, only one. Huh? Sir, no. Constant acceleration is subdivided into two categories. Constant, this acceleration is constant. It is either uniform or non-uniform. Means every time you are facing an acceleration, this every time is every and variable accelerated motion. Chalo, let's do it. For our clarification, I am writing. Means constant accelerated motion means that every instant you are facing an acceleration. Now that acceleration can be uniform and can be non-uniform. Suppose right now the force is 10 Newton. After 1 second the force increases by 2 Newton. So the force becomes 12 Newton. So the acceleration changes. So it will be non-uniform acceleration. If I say uniform acceleration, that means constant force. Acha. People do confuse this one thing. Okay, we are all talking about what 1D motion. Please listen to this very carefully. We are all talking about 1D motion. We are not delving any other things. We are only doing 1D motion. So, and over here, this is variable force. And this is also variable accelerated motion, means sometimes there is no force, sometimes there is force. So this is also, I can write it as variable force. Now sir, which is the first thing we will be doing? We will be doing, the first topic is uniform accelerated motion. Uniform means the force is always constant along a straight line. The force is always constant along a straight line. Yes. So first we will be starting off with uniform, then we will be delving into non-uniform. Okay? Chalo. Now, so let's start off with, since I have written constant, we start off with uniform. No need to write constant. Uniform accelerated motion. Now this is the topic where plenty of questions to come in all competitive examinations, plenty. So this seems to be an easier one. No, this is very tough. Non-uniform is easier than this thing, okay, but this is literally complex. Okay, so one thing for sure, uniform means force is constant. Force is constant. The constant magnitude of force is acting on the body, which produces a constant acceleration. So force by mass. Simple, yeah. And yeah, how to measure? We are coming on to it. By rate of change of velocity. Now, sir, what is acceleration and how it is measured? Now, acceleration is measured as rate of change of velocity. What it means? Sir, say v minus u by t. You have done this thing, yeah? Okay, fine. I will write in this way. Velocity at time instant t2 minus velocity at time instant t1 by t2 minus t1. This is class 9 expression. This is a different expression. Same thing. Okay. Same thing. Okay. So I have written in this format. Same format. Okay. What it means? Let's take an example. Let force equals to 50 Newton. Mass of the body is 25 kg. So acceleration becomes 2 meter per second square. Okay. If at t equal to 0. Now over here, see, we are again coming into the point of t equal to the 0 or t equal to anything. If at t equal to 0 means t equal to 0 means suppose when the observer starts calculating the time. If initial velocity, now u actually signifies what? V at 0. What is u? U signifies v equal to 0. Or sir, is it necessary v equal to 0? No. U means initial velocity. Means suppose these are very complex things. So how you write this thing? I write like this thing, v0. Chalo. Say it is plus 10 meter per second. Sir, what it signifies? Plus 10 meter per second. Plus 10 meter per second signifies जब ऑब्जर्वर कैलकुलेट करना शुरू किया टाइम इंटरवल, मतलब जब ऑब्जर्वर ने घड़ी दिखना शुरू किया तब ऑलरेडी बॉडी कहां पर मूव कर रहा था? +10 के तरफ बॉडी मूव कर, +10 के लेकर बॉडी मूव कर रहा था, मतलब इट वाज मूविंग अलोंग द पॉजिटिव डायरेक्शन ऑफ द एक्सिस. बट बॉडी कहां पर है ये हम लोग को पता नहीं. बॉडी कहीं पर भी हो सकता है, मतलब दिस मींस अगर ऑब्जर्वर यहां पर हो तो बॉडी अगर यहां पर है, ओके, तो बॉडी यहां से यहां तक मूव कर सकता था. अगर बॉडी यहां पर है तो बॉडी यहां से यहां मूव कर सकता. So whatever body can be placed anywhere, but it will be having +10, means it is moving towards the positive direction of the axis. And acceleration 2 meter per second. Okay, so v at 1 second कितना होगा? So simple sir, 10 plus 2, 12. v at 2 क्या होगा? इसके साथ 2 add up हो जाएगा. 12 plus 2, 14. Wow. So it's a constant change. So change of velocity is constant. मतलब velocity change कर रहा है, but एक fixed value से कर रहे हैं. जब भी ये होगा, जब भी the change of velocity is constant, then only the motion is uniform accelerated motion. जब change of velocity constant होगा तब भी हम उस motion को क्या बोलेंगे? Uniform accelerated motion. Okay, so this is the first concept कि acceleration is v minus u by t. You write it in this format, I write it in this format. Done. Next we come up with another term which is termed as average velocity. Now this is very interesting. Average velocity, देखो ये average velocity क्या है? अरे सर आपने तो अभी पढ़ा है average velocity. Average velocity means displacement in the time interval t1 से t2 तक by t2 minus t1. एकदम सही है, perfect. But इसका एक beautiful चीज है, क्या? वो हम लोग करेंगे. ओके, वो हम लोग करेंगे. एक और ब्यूटीफुल चीज है एवरेज वेलोसिटी की. जैसे if I say something 2 5 8 11 14 17 20 23 26 find the average of the numbers. देखो कौन जल्दी बोल सकता है find the average of the numbers? You can't. You have to calculate this thing. I will say the average of the numbers is how much? It is 14. Sir, how this is possible? How you can say without calculating it? Yes, I can say without calculating it the average of the numbers is 14. तुम कैलकुलेट करोगे बट मैं बिना कैलकुलेट करके बोल सकता हूँ average of all these numbers is 14. So average of the numbers is equals to 14. Sir, how? Yes, we will see to it. Okay, this is a beautiful logic. So I hope this portion is clear. Now we will be speeding up, okay, because we need to speed up. We have done the basics. I will be speeding up the whole scenario. If you people be having doubts regarding this, you can give me a call in the WhatsApp number or call me, okay. If you feel ki no sir is a bit faster, because see basics we have done very carefully. Now I have to speed up. If the difference of the numbers are constant, see it's 2 5 8 11 14 17 20 23 26. See the difference between them is constant, okay, check it out. The difference is always constant. Then it only happens if the difference is constant. If the difference is constant, if the difference is constant, or else you can't do it, okay. If the difference is changing, you can't apply this thing. This is only applied if the difference is constant. If the difference is constant, then average is given as first number plus last number by 2, or second number by second last by 2, or third number plus third last is equals to 2. This is the basic thing, okay. So what it comes to, sir, you take any 2, sir, 2 plus 26 by 2, 14. Sir, second is what? 5 plus 23 by 2 at 14. What is, sir? 8 plus 20 by 2, 14. और बीच में देखो, बीच में 14 ही बैठा हुआ है, इस पे 4, इस पे 4. सर ये आप 9 नंबर दिया, अगर 8 नंबर होता, मतलब अगर 26 नहीं होता तो क्या होता? 2 plus 23 by 2. Yes. So this is the basic concept. So ये डिफरेंस देखो कांस्टेंट है. जब भी तुम्हें डिफरेंस कांस्टेंट है तो तुम ये कर सकते हो. So अगर हम लोग ये कहें कि यूनिफॉर्म एक्सेलरेटेड मोशन, ठीक है, ध्यान से, यूनिफॉर्म एक्सेलरेटेड मोशन, इनिशियली u इज द इनिशियल वेलोसिटी, मतलब जो हम लोग का टाइम कैलकुलेशन में इससे कोई भी t1, मतलब इसी को हम लोग बोलते हैं कि v इक्वल्स टू t1 डॉट 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 डॉट, सोचो v, मतलब इसको मैं बोलता हूं v इक्वल्स टू t2, ओके. सो इसके बीच बहुत सारे वेलोसिटीज है और यूनिफॉर्म